Hi, this is the second video for week 2 trigonometry. This is the second of 10 videos for week 2 and covers right-angled trigonometry. These videos are intended to help you to work through the online content for week 2. We recommend that you watch these videos with your pen and paper and pause at the relevant times to try the examples for yourself. Right-angled trigonometry. We're going to start with some important names in right-angled trigonometry. So before we've spoken about the hypotenuse. And the hypotenuse is always opposite the right angle, and it is the longest side. So then we have our angle of interest, and we're using theta here. So here we draw theta, we draw a circle with a little line through like that. So this is our angle of interest, the angle we're looking at. Then opposite that angle, we have our opposite. We write opposite, or we could label it with an O. So our hypotenuse, we either label with the hypotenuse, H there. And then here, the angle that is adjacent to, next to our angle of interest, theta, is our adjacent side there. So the names of the two shorter sides are always relative to the angle of interest. If we were to look at theta up here, our opposite and adjacent would change. So here if we look example 4, we've got our theta here, our angle of interest. We've got our right angle, so here we have our hypotenuse. Our angle theta, opposite this we have our opposite. And adjacent our angle we have adjacent. Here we have the same triangle, but we're looking here, our theta is this angle up here. Our hypotenuse is still opposite our right angle. So here our hypotenuse has not changed. But now our opposite is this side here, and our adjacent is this one here. So our opposite and our adjacent have switched positions when we've switched angles. Now we look at our trigonometric ratios. We have 3 basic ratios formed by the following rules. Our sine of theta is our opposite divided by the hypotenuse. Our cosine theta is the adjacent divided by hypotenuse, and our tangent theta is the opposite over adjacent. So here we label our sides. Here's our opposite, our adjacent, and our hypotenuse. So we remember these with so, ka, toa, where S is for sine, opposite, hypotenuse. Sine of theta is opposite divided by hypotenuse. Here is AC divided by hypotenuse AB. Then ka. Ka is our cosine of theta is adjacent divided by hypotenuse. Here our adjacent divided by hypotenuse is BC divided by AB. And toa, tan of theta, is opposite divided by adjacent. So tan of theta here is opposite over adjacent. Here, opposite over adjacent is AC over BC. And we can also say here, if we take it through, our tan of theta is also sine of theta divided by cosine of theta. So we can work this through at a later date. So example 5, we have our triangle ABC shown. We want to use Pythagoras theorem to find the length of the hypotenuse. So here, well, we know Pythagoras theorem, c squared equals a squared plus b squared. Here's our c, there's our a, there's our b. So c squared is equal to 9 squared plus 12 squared. C squared equals 81 plus 144. So c squared here is 225. C is the square root of 225 is equal to 15. So this length here is 15. So now our sine of A. So remember, so, ka, toa. So sine of A, this is our angle A, is our opposite divided by hypotenuse. So sine of A is opposite divided by hypotenuse. Here is 9 on 15. Our cosine of B, so now we're looking at angle B. Cosine is adjacent divided by hypotenuse. So here's our b, our hypotenuse stays the same, and this side here becomes our adjacent. So here, adjacent divided by hypotenuse. And this is also 9 on 15. So we're using the same thing. So we notice that the sine of angle A is equal to the cosine of angle B. And our tangent of angle B, here's our angle B, here's our opposite, and our adjacent. So here opposite divided by adjacent, here gives us 12 over 9. So moving on to example 6, we've said tan theta equals 4 on 9. So they haven't told us where, so we're just going to put theta here. So tan TOA is opposite over adjacent. So here's our angle, this is our opposite. So that is our 4 over our adjacent is 9. So here we can use Pythagoras' theorem to find here our length of our hypotenuse. So we know a squared plus b squared equals c squared. So here 9 squared plus 4 squared equals c squared. Here we've got 81 plus 16 equals c squared. 97 equals c squared. So c is the square root of 97. So square root of 97. So we want to find sine of theta. Sine of theta is so. So here we know it's opposite over hypotenuse. Here's our theta. That's our opposite. This was our adjacent. And this is our hypotenuse. So here our opposite is 4. Our hypotenuse is the square root of 97. And for cosine of theta is our ka. Here adjacent over the hypotenuse. Here, so our adjacent is 9 and the hypotenuse is the square root of 97.